Damn it, I'm not feeling this music either. I'm a little bit sick of my normal electronic music. I don't know what to play instead though. Um, hmm. I'm just quickly. Haley Williams? I don't know who that is. Let's see. Is this gonna be some girl music? Let's see. I see a whole bunch of singles on Spotify. You know what I mean. These are all just okay. I don't know why they're all listed as singles here, but you know what? Let's see. Zissou. 17 singles instead of an album. Okay. That's a choice. Singer from Paramore. Oh, that's cool. Okay. I take back my girl music allegations then. This isn't bad. I'll keep listening. Hey Lucas, I'm doing good. How about you? I did watch that thing that you posted. Um, I didn't even know how to start figuring out if it's real or not though. Haley Williams did sound familiar. Damn, shots fired at the music. Yeah. This is Haley Williams who FA suggested because I'm kind of sick of the music that I normally listen to on stream. Uh, Haley Williams. If you've heard of Paramore, she's apparently the lead singer. I think you mean fanboy, Lucas. Like FAN. Or maybe you're also a femboy, but I think you're there's a big difference between those two things. that that's a bit of a different thing. People are also that. And there's nothing wrong with it. This is a safe place. It is funny to accidentally call yourself that. Chug. Dude, that Georgie mode is so great. The 5 streak also, thank you. Oh my gosh. What's funny? Gonna boys, I was gonna bully so much for your second suggestion, and you're already judging me for it. Hmm. I mean, this isn't bad. If you're gonna suggest like country or something, I'll probably bully you for that. To us, this song is like it feels like halfway to being country. It's not bad though. 556 minus 9 by 39. 45 ACP. Burn It Down? By Paramore? I don't think I heard that one. Hey, Viramella. Gibran Alcocer? Let's see. I sure do, Shug. Oh, from Linkin Park. Okay. Oh, yeah, that's right. You said Linkin Park earlier. With the span of vectors? Yeah, sure. It's like you just want to... Are you trying to do a specific problem, or do you just want me to tell you like what they are, or like what span is? We'll do Shook. It probably won't be for a minute, because I want to beat Sifu. Oh, for like the sum of cubes? Okay. Was it Country FA? I mean, well, now I'm curious to hear what you were gonna suggest. Yeah, the sum of cubes is a good one. Yeah, sure, absolutely. As a fanboy, yes, you will. Is that a Pizza Heart? It is. Wow, it's a good emote. So the casual definition of span, Slim. Thank you so much for the raid, Slim. I hope your stream was good. I saw you're doing you did a proof of the Pythagorean theorem, right? I saw that. Hey, Rex. As far as PP music goes, this guy isn't bad. I got sick of the electronic music that I've been listening to, so I've been taking suggestions from people and also bullying them for doing that, because that's just the kind of person who I am. Some teachers kindergarten maths to Rex. Hell yeah. Fun stream today of classic sounding music. That's nice. This is someone who Lucas suggested. Get Gibran Alcocer. I'm working on it, Viramala. Okay. Joseph, congrats on the first. I can believe because Linkin Park ruins the chill vibe. I'll queue up that song. Burn It Down, Linkin Park. I did used to listen to Linkin Park a lot. Actually, I'll just skip to it now. Okay. The kind of casual definition of span this isn't the actual math definition is given a set of vectors v, or given a set of vectors, the span is everywhere you can go using linear combinations of those vectors. I already have to bully you. Yo. It's probably I need to turn it down just a little bit. Oh, you know, I've heard this. Not for a long time, though. Okay, so, yeah. That's what we're about to do here. So I think the first example that I want to show is, I guess, kind of like a nice example. If our set V, let's say we have the vector 1, 2, and the vector -2, 3. It's gonna be folk. Oh, I I probably wouldn't get it, so I don't deserve your officially hate watching. Honestly, folk could be kind of cool. That has me curious, but if you don't want to be bullied, I understand it. And so the way that we think about the span of this set of vectors is, that's true. We would say that the set of vectors spans all of R2. And so if we have our normal x and y axes, let's say our first vector 1, 2 is right there. And then the other vector -2, 3 is right here. It means that we can take these vectors, add them, stretch them, reverse them, and we can get anywhere else in the plane that we want. So if I randomly chose this point in the plane here, actually, let me choose like that point in the plane there. I would take maybe this vector here, reverse it out to here, and then take this vector here and just kind of bring it the rest of the way to that point. And the point is that you could do this with any point in the R2 plane that you want. And so that means this set of vectors spans all of R2. And there's a way to check for whether it spans that we'll talk about. Yeah, and so Rex is saying the case where things can go wrong. Oh, we're back to the piano music now. So if I instead take the vector 1, 1 and the vector 2, 2, then the thing that goes wrong here is one of my vectors is right here, but the other one is in the exact same direction. And so no matter what we do with these two vectors, we are always restricted to this line here. We can never get to a point that's, say, right there. And so that's why it's really important to have vectors that point in different directions. The magnitude doesn't matter at all, really, because we always like can scale them as we want, but they need to point in different directions. And so we would say this set of vectors does not span R2. It spans in like a one-dimensional space that exists in R2. Basically, it spans all vectors such that y equals x. And so 2 dimensions is like simple. In higher dimensions, it's a little bit more complicated. If I gave you 1, 0, 1, 0, 1, 0, and 1, 1, 1. Something's going to go wrong here, because I could take these two vectors and add them together to get this third vector. And when that's possible, it means like we have no hope of spanning R3. So now we're talking about 3 dimensions. I'm guessing vector space is just the entire space 2 vectors can occupy. It can be more than just 2 vectors, but that's basically the idea. And so the reason why is if you were to draw these vectors out, they would all lie in the same plane, basically. So I'll do my best to draw this 3-dimensionally. I'm not an artist though. And unfortunately this example doesn't work in 2 dimensions, so I kind of have to try to do this 3D drawing. So 1, 0, 1 is right there. Wait, I'm sorry, it's not right there. 1, 0, 1 is in the XZ plane. Zero, 1, 0 is on the y-axis. And then 1, 1, 1. Oh, this is kind of hard to draw. I don't know if Desmos can do vectors is the issue. Okay, you know what? So the thing that I wanted to do here, Virmal, is draw the last like 1, 1, 1 vector and show that these are all just going to exist in the same plane. It's a little bit too hard for me to actually draw that and it be helpful though. So let me try a different example entirely. That will hopefully convey the same point. So let's go back to 2 dimensions. And let's say we have the vectors, what are the vectors I was using before? -2, 3. And then let's say I throw in a third vector into this thing. -1, 5. Restricted functions? I don't know what you mean. Like how? Like we haven't talked about like we're not, when it comes to vectors, we haven't talked about functions at all at this point. And so this set of vectors, it also spans R2. For the reason that we said above here, like these first 2 already span R2 on their own. And so this third vector is really contributing nothing. Kind of like me. -1, 5. Nothing is still something. Like these first 2 vectors were already enough to get us the entire R2 plane. So we could have removed this third vector and been completely fine to span R2. All 3 of these vectors exist in the same plane, And so just because we've added in a third vector doesn't mean we've gotten anything new. And the exact same thing can happen. And so for trying to span like R2, two-dimensional space, that's fine. Like it's unnecessary, but it doesn't hurt you to have it. If you want to span R3, like I could take all these vectors and just slap a 0 on them. 1, 2, 0. Minus 2, 3, 0. Minus 1, 5, 0. These are the exact same vectors, but I've just set all their z values to be 0. But for the reason we just said, like, this is still the exact same situation we drew up here. Like, even though we have 3 vectors here, we can never get outside of the xy plane. Our z values will always be 0, no matter how we add or subtract these or scale them. So we just never have a hope of spanning R3 when these vectors are dependent is the word. Linearly dependent. We would say these vectors up here are linearly independent. Desmos can do vectors. Okay. Rex is suggesting another website. That's just occupying empty space? Hell yeah, I can do that. I don't know how to draw a vector in this. Add object? Oh, hey, look at that. Get rid of you. So what was the example I was trying to draw? 1, 0, 1. Thank you for finding this, Rex. And 1, 1, 1. So this is the example I was trying to draw, and this is like, hey Najaf. And so this is a nice way of saying, like, these 3 vectors are also dependent. So we said, like, if you sum up the first 2, you get the third vector, and that's a sign that these are dependent. And geometrically, that looks like as these all exist in the same plane. Can we guess the equation of this plane? Like, you can see I can, like, line them up, and they all look like they're on the same line. How would I quickly get... I'd have to do a cross product, wouldn't I? I don't want to do a cross product. Yeah, it's not worth it. I think a system of equations way too, maybe. But meh. Thing is dependent because 0D doesn't exist, so what? It means it makes you sound way smarter than usual. Is there a way to pinpoint something 2D in a 3D space? Yeah. Like, two-dimensional spaces exist inside of 3 dimensions, and that it goes for higher things too. So you can have like a tilted two-dimensional plane that exists in 3-dimensional space. I have questions on possible on this topic. I don't know what that means, Viramala. And so a fact that's important to know about span is that in order to span Rn, so just an n-dimensional space, you need at least n linearly independent vectors. Yeah, Virmal, I don't know what that means. I'm sorry. Physics GAE teacher took 14 lectures, an hour and a half each to teach vectors. I have them all backlogged. It's supposed to be an easy topic. I don't think vectors can be weird to think about. I don't personally find them especially difficult. That's not true for everyone though. IITS, I don't know that. I do play chess. I'm rated, I think, around 1500 on Lee Chess. You have a quiz on the span of vectors today. Oh, nice. You can check if a set of vectors is linearly independent by putting them in a matrix and finding the determinant. This is like the long way of doing it, but it'll always work. The determinant is not 0, then they are independent. If it is 0, they are dependent. I know calculus, yeah. I'm not going to university right now, nudge off. That was interesting to hear, obtuse, and welcome in. Channel point option to play a chess match against you? Maybe. If some, like, if you want to play chess, we could just, like, do it, but I don't know. They can kind of, like, take a while depending on the time control. Yeah, sure. Do you like Lee Chess or chess.com? I can do either. And it'll be after we talk about this. Okay. Adish, I do some tutoring. That's my job. Maybe like 5 minutes, I think. I don't want to spend like a... If someone comes into the question, I don't want to keep them waiting for too long. Okay, and so in order to, so these are the important things to know about, like, 2000? Holy crap, Lucas. That's the important thing to, like, know about when with questions about span. And so to do an example of this piece here, let's say the set of vectors we have is, or we can verify it for the set of vectors that we were working with before. Let's say this one. If that's the set of vectors, we can verify that these are independent by putting them into a matrix and taking the determinant. So 1, 2, minus 2, 3. You find the determinant of 2 by 2 matrix by multiplying those two minus multiplying those two. So 3 minus -4 is 7. 7 isn't 0. So that confirms that these are independent and they do span R2. 1200 during peak chess era. Oh, nice. So yeah, I think that's what I have to say about span, Viramala. It's often quicker to just guess and check. If they're dependent, like with these, it's a good idea to just try to mess with the first two to see if you can make the third one. And so with this one, it's a little bit more like clear that you just add the first two and you get the third. That can save time on finding the determinant. Hey, Fembucks, we're doing well. Konnichiwa. How does chess.com work again? I might need to sign back in. Oh no, I am signed in. We can do 5 minute, I guess. And then how do I get it to be a link? There's a way that you can make a, there we go, challenge link. Oh wait, or if I can just challenge you. Great game. Lucas Q5. Complex numbers, yeah. Oops, I wasn't typing it. 1939. God, I'm kind of nervous. It'll be random, standard, 5 minute. All right. Don't help me, chat. No cheating. Uh, hmm. You know, I'm regretting what I did. I'm regretting my life choices. Uh, it's funny. I actually I was just digging through my old stuff and I found my United States Chess Federation like players card from when I played like a few tournaments as a kid and then I quit. But I do have a USCF rating. um. Hey, Dr. L. I'm not very good at chess. I'm too lazy to actually calculate. I just kind of like get bored. That's my biggest problem with chess, I think. Well, okay, I'm a little bit worried here. Am I doing a stupid? Don't help, please, Viramala. Am I still doing a stupid? Viramala don't help. Hmm. Oh shoot, it's 5 minutes. I shouldn't take all the time in the world. This is gonna be my only game, Ritesh. I don't want to spend too much time playing chess. Um, I probably made this rated. That's my bad, Lucas. It's probably not a good idea to make it rated. I forgot to check that. I'm sorry. You only know how to move the pieces. Oop. My dad knew strategy and has won contests. I'm there trying to make this thing symmetric and pretty. I feel like there's people who appreciate that. Um, Homeomorphisms are really interesting to look at. I wouldn't know, I guess. Don't try to make you feel good about it. All right, fine. Feel bad about it. Hey, Sockno. You're bad at chess and you should feel bad, FA. This is a little bit awkward. I don't, I should be better, but... Oh, wait, I should play this move. There we go. I'm very happy. Teacup to donut is an example of homeomorphism as no cuts or breaks in topological spaces happen when converting from one shape to another. Oh, that's what a homeomorphism is. Okay. And like I said, I've heard that intuitive explanation. Oh, fuck. My time. Ah! I think I threw. I I have thrown this. $35? I don't know what that means. Yeah, GG, Lucas. Oh, I know, Goofy. I I needed to play that rook move way earlier. Uh this Rook to a6. I had that for a while, and I never saw it. Like after this, I think would have been better. A time warning. Oh, okay, okay. Viramal, I don't want help. That's cheating. GG, Lucas. You did gain points, amazingly. You lucky shit your pants halfway through. No, I want to get back to the math. Bishop could have moved to the same diagonal as 7th rank pawn. I mean, I wanted to bring my bishop out here, but the pawn would have taken it. Oh wait, maybe you mean up there. I don't know. 3 years and 1600? That's kind of crazy. Other bishop. This one? How? It was kind of stuck in limbo. Oh wait, oh you mean like towards the end here, I could have played that? Well, no, I couldn't. Not there. Maybe. I don't know. I think I've heard of that kid. Yeah. Playing with stream is harder, yeah. Rook a6 could have captured your pawn with his rook. Yeah, I mean, with that I was hoping after the rook a6, I was planning to just like trade off the pawns, because this pawn is way more dangerous than my pawn. My rook was kind of in the way and didn't have good squares to go to. Is this a redeem? No. I could make it one. If you want to play chess sometime at FA, we can too. When you went from 500 to 1900? Wow, that's crazy, Lucas. Is that a voice call from someone looking for Rishi? Can't tell you how I was tempted. Someone they could get me in contact with Rishi Sunak. Only if we listen to your music? Okay, FA. We can do that. Stop mathing with... So, Virmal, I kind of said everything I had to say about span. I don't know what else you want to hear. Sabotage game successfully? You did. Yeah, if you want, we can do that. All right, well that's way too much for me to review, Viramala. Those are 1, 2, 3, 4 pretty big topics right there. I can't explain them all. And I guess we already did span, but like you're asking a little bit too much here. LU decomposition. Let me bring up my textbook. So there's something special about LU decomposition. First 2 letters of your name. So the special thing about LU decomposition is that U is the result of doing row reductions on a matrix. And L is like the record keeping of the reductions that you did. Without, yeah, oh yeah, if there's row exchanges, then it's a little bit trickier. Or just, there might not be an LU decomposition if you need row exchanges. Oh, I think there's like PLU or LPU when row exchanges are involved. Is there... Like, what's the easy way to get to LU? Do you really just have to do row reduction and... I guess you do. I mean, it's quick enough to do for a 2x2 matrix. Can't play chess worth a damn. Can hold my own against beginner/intermediate. Playing recently on an off-balancing strategy and make as many pieces as movable as possible. Okay. That's something. Same strategy of alpha 0. Oh, really? Okay, so what example do they use in the book again? They do a 3x3. All right, we'll use their 3x3 example. It's kind of a funny example of a matrix. This is like, I forget what the word for it, it's like a diagonal matrix, but when you have the two extra diagonals there, I forget what the word for that is. But basically you find LU decomposition by doing row reductions. And so we can find U directly just by getting the lower triangle to be zeros. Oh wait, I think, does U also includes a diagonal, doesn't it? No, never mind. What was I? Okay. So if I want to get, so I'm working on these two entries first. I want to make them both 0. Our work is already done for us with that one, so let's work on that one. If we want to get that to be 0, we should take half of row 1 and subtract it off. So let's do that. 2, 1, 0, 0. 2 minus a half is 3/2. 1 minus 0 is 1. 0, 1, 2. And then just one more step. I want to get this one to be a 0. That'll give us U. That'll be our upper triangular matrix. So we're going to subtract off something times row 2. We want to subtract off 2/3 of row 2. Two minus 2/3 should be 4/3. Okay. And so this bad boy right here is U. we actually have all the information that we need to find L as well. We just need to do a little bit of thinking. So the LU decomposition, I'll fill in L in a second. U we just found is 2, 1, 0, 0, 3 over 2, 1, 0, 0, 4 over 3. And so L is lower triangular, so the upper zeros, the upper part here is always 0. And we never multiplied any rows through by a scalar. Well, you don't really have to do that for LU decomposition. So we have these ones all here. But we did take row 2 and subtracted off a half of row 1. And so we're going to have a -1/2 right here in row 2 in the first column. And then when it came time to deal with row 3, we never involved row 1, so that's a 0. But we did involve a -2/3 of row 2. So we'll have a -2/3 in the second column. And that should be our LU decomposition. Let's fact check that. Oh, I flipped the sign? Really? Why is it positive? Oh, because when you're doing when you multiply these back out, you're going kind of in the reverse direction. So you do need to flip the signs because we subtracted off rows to get to U, but when we multiply U by something to get back to the original matrix, we want to add instead. So we're taking U when we're going to add things back rather than subtracting off. But yeah, I think it's really everything there is to LU decomposition. Just do row reductions until you get zeros in the lower left corner there. And that's already your U. The L you figure out by keeping track of what row operations you did. And this only works if you're not doing swaps. Swaps, it's going to look a little bit different. I think you need a third matrix or something. So yeah, I hope that helps. Let me know. Hey, Atharv. The main diagonal, it should always be 1s for this. It will be possible to have it not be a 1 if you were to multiply row through by a scalar. Like if I multiplied row through by a half, I think we would have a half there. I think. But for LU decomposition, you don't care about getting 1s there, so there's no point. Or like, it's enough just to have the pivots. You don't need to make them 1s. So I don't think you ever actually need to. Hey, Syntax. Yeah, that will be a good idea to do this multiplication back out and check that we get the same matrix. Yeah, sure, syntax. That column times that row. That column times that row. That times that. That times that. 1/2 plus 3/2 is 2. 1, 0, 1, 2/3 plus 4/3, 2. Nice. You're saying pi. I'm intensely curious if Wolfram Alpha can solve this. So it might just give us a numerical estimate. Desmos says in numerical estimate is pi. Interesting. GPT-5? What did they update? Wolfram Alpha just quits. Do people actually search most beautiful painting in Wolfram Alpha? Oh, and they don't want to comment how many monsters are in Loch Ness. Everyone is in on the conspiracy, I guess. There's at least 12 Loch Ness monsters that I can think of. How do we get pi out of that? Oh, no, Tharp. Never feel embarrassed to ask stuff like that. This is Wolfram Alpha, and if you don't know it, it's a really amazing website. It'll solve equations for you. So if you want to like make it factor or quadratic, it'll do that. X equals -2, x equals -1. So it can do like algebra problems like that, but it can also do almost any calculus problem you want. Like it can't do competition problems usually, but just like normal problems you encounter as part of like a calculus class, it can do pretty much all of them. And if you don't know this one, you should also know the freaking auto. I hate autofill. It never autofills when I want it to. Oh, it's just integral calculator. That's why. So Wolfram Alpha, they make you pay to see steps. So let me. What? Oh, because I put a D in there. Like, they'll actually show you steps for the problems too, but you have to pay. And they got rid of the trick that I used to use where you can just take their next step and plug it back into Wolfram. They made it so they covered up the actual next step now. So I don't think you shouldn't have to pay for stuff like this. And so the integral calculator is actually just completely free. The only price you pay is you have this dude's photo staring at you as you scroll around. Whatever you do, you can't escape him. But other than that, it's free. Not a bad price to pay? Yeah, Papadoria. The few articles you found, this one gets the gist. For LMs getting gold. Intedex, I'm still thinking about your thing. Be free from money rather than having to pay to be free from a creepy man staring at me. It's funny. Yeah, I mean, AI doesn't have to be perfect. It just has to be better than humans. And that's going to happen sooner than than some people might want. Considering an approach to express those products of cosine as a sum, found something that could lead to the form sum cosine xan over 2 to the k. Need MacGyver to beat AI? Oh, I haven't heard of that one, Papadoria. Hey, Phobos. Oh, this is going the wrong direction. This is an infinite product representation of cosine. Wait, was there a sync? I didn't see that. Was it on the link before? Further down that page? Ah. Wait. Got him into control F for a reason. No, there's only sense on this page. Sync. Oh, hey, there's sync. The other Stack Overflow? Was it this one? Oh, yeah, it is. Can you represent cosine as an infinite product, and can those products be exchanged like sums? I don't know. All good. Can you exchange infinite products? Infinite product solutions, shipping and return policy. Okay. You exchange diapers at Walmart? That is a good company name. This is only for limits in infinite products. Maybe you have to go to the infinite mall. A CEO named Wallace? I don't know that reference. Zundamon? Oh, I haven't seen this channel. Oh, Wallace product is a thing? Okay. Oh wait, have we been on? Oh, we've been on Gibran this entire time. To be honest, I'm kind of feeling it though. A near impossible dream. It's gonna stay impossible for a little while longer. So sorry. Oh, it's for pi over 2. Okay. Why would you need this when we have 22/7? Came from a stream recently. Honestly, this kind of sounds familiar. Oh wait, wasn't it for a Papadoria problem or something? I feel like it was on my stream and then you talked about it on your stream. Yeah, Papadoria. Where AI was fine with I. That sounds right. But this seems like an actual, like, I idea. We don't have the exact same thing. But like, thinking about series feels like a good idea. Oh. Hey, learn and grow up. What's up? This is a nice stretch. Why does one need 22/7? They can have Ramanuzan series. Just gives you crazy accuracy. Yeah, that's true. The 22/7 thing was just a meme. 3 gang, rise up. 4 gang, rise up. Why did the physics department show up? Yeah. That's a great fractional representation of pi Papadori. Oh my god. Wait, this is the trifecta here. An integral, a product, and a sum? I think I've made this worse. I think life is worse for having seen this. What about union? Man, someone needs to make problems actually solvable that's like this, because this is just, it's kind of, it just kind of looks cool. Oh man, they make a problem where like you end up interchanging, like reversing the order. Like you switch to sum in the product, and then you switch to sum in the integral, and then the integral in the product or something. I wouldn't want to do a problem like that, but someone else should make the problem and solve it, and then I'll just read the solution. I don't even know if it's probably not valid to interchange those. Yeah, I'm going for applied math, not for this, like, let's make an annoyingly hard problem and solve it. My homework may have one, I hope not. Instead of some of the traditional integral items, we multiply. Wait, are you talking about like the definition of an integral, Papadoria? Like, can you define an integral with a product instead of a sum? Yeah, like I mean, I kind of figure that my streams would stay the same, and just instead of studying as my filler, it'll be homework as my filler. I've already thought about, because I've saved like all my old notes and tests and stuff. I've have thought about trying to resolve some of the tests from my last year of my undergrad. But the issue is I've forgotten a lot of it, so I'm trying to like relearn it. But what happened if we did that? Any good use cases? Apparently this is a thing. Let's find out. Oh, maybe Slim, yeah. Fucking. Sorry. I see F, K, and N all together, and ugh. Am I regaining my sanity? Doesn't sound too fun. How to make the discrete product continuous? How do you increment k? Yeah, okay. What? Okay, this is a little bit too weird for me to understand this, but maybe Papadoria. I it probably isn't helpful as far as I know, but it seems possible. The new symbol? This like weird integral? Honestly, I thought it was just a typo. Oh no, that is just an original, or not like a typo, but just a weird integral. A product over a continuous range. Huh. Interesting. Maybe in DEs, maybe. Oh, no syntax. Like, this acronym is used in physics too, and it kind of, I feel like they just shouldn't. um. Anyway, it's the link that Zach put. So, complex definition of cosine seems worthy of considering. Oh, I feel like I'll get in trouble if I said it out loud. Is there a way that I can hint at it? The the P stands for porn. It's not a good thing to Google. You don't want to Google that. The the C, it's a word that starts with CH, and it's a thing that you really don't want to. It's a very bad thing. Not sure anymore. I think it was an insane idea all along. Okay. Song gets in trouble. Yeah. I mean, if you Google like what does it stand for, I'm sure you would find it. Um, I just don't Google for that thing. That's what'll get you in trouble. The cosine product is the same as product from n equal 1. One to infinity, presumably. No, it's not cerebral palsy. Oh, okay, yeah. Why is that true? You found it? Okay, yeah. Yeah. Cosine products, same. The I don't know why did I add an extra parentheses there. Um, using sine Euler product for cosine. Sine Euler product? Long. Okay, I'll trust you then. um. Yeah, this feels like it makes the problem worse. um. Well, it does look a little like sine x over x, right? Is that a good thing? Could that help us? I mean, I don't know if it helps with the product. I don't think it helps. Just gonna wait on my pay grade real quick. It's never been in my pay grade. Okay, back to our Lord and Savior, Wolfram Alpha. What if I gave it just the product? Come on. No, no. No, let me highlight the thing I want to highlight. I hate you. Why do you hate me? Stop. Fine. I'll rewrite you. Is that what you want? It hates me back. I don't blame it. One of the people actually made this site, Stephen Wolfram, streams on Twitch, funny enough. And I'm sure he's hate watching me right now. Oh, that's just an approximation. Maybe expanding the cosine product into sums could reveal a pattern. Like doing product to sum? I was wondering about that. I wasn't optimistic if there would be a pattern, though. That emote is really good. Uh, I can't imagine there'd be a pattern there. What's like prime numbers are gonna mess that up, I feel like. Oh, Felix, it's been a minute. Hello. How have you been? You know, FA, we could go back to Haley Williams just for you. Because I did listen to like 1.5 songs. And then I got distracted. Hey, thank you for the kind words. Pattern B going to k instead of infinity, you get 2 to the minus k multiplied by cosine. What are the... Oh. That seems reasonable though. Like, can't... Well, does it seem reasonable? It doesn't follow a pattern though, does it? A puzzle in Zach's Discord? Honestly, I'm not a huge fan of puzzles usually, but we can at least read it. It wouldn't be just harmonic series though. There'd be some like sign business. Like the signs wouldn't always be plus, I think. This is actually a nice song. I'm glad I went back to her. What is this? Ah, True Believer by Haley Williams. Uh, oh, Felix, I read that, and I have no clue how to even start it. I do remember seeing that though. That one's gonna be out of my pay grade. Yeah, Paramore. Um, wait, I wanted to understand what the pattern is with the signs. Here, be making dinner. Okay. Because if we can say something about the signs, like hope isn't lost for that approach. Um, Is this why did syntax had 3 cosines though, I think? Oh wait, yeah, I'm doing this wrong. I don't really know, Papadoria. So, okay, the signs aren't really going to have much of a pattern, are they? Okay, so there's 3 cosines because that one and no? I don't know why there's only 3 cosines. Yeah, okay, I think this is getting stupid. Hmm. Well, look at this. That's almost the exact same problem. Yada, yada, yada. Okay, yeah. Wait, is that legit? But he just interchanged an integral and a real. Yeah, I'm confused about that. Same thing, Papadoria. Hey, Papadoria, is the YouTube audio coming through? Sorry, is this audio coming through to YouTube? It shouldn't be. but I might have messed that up. You can't? Okay, good. I don't want that to happen because of copyright issues. And I recently had to like remake my entire OBS setup. And I wanted to make sure that I didn't mess that part up. Oh. Is it really that simple? I guess it's okay. So what does he do? He's making them all negative there. Really? What is that? Riemann zeta? Uh, Not as far as I know, Papadoria. So no, you always split the integral up into two separate ones. I don't know if there's a technique to keep them together when you integrate it. Uh, er, hmm. No, this is not the question we have does not have the square. I'm just wondering if we can use the same technique though. I'm trying to understand what he's doing, and then I want to know if we can do it to ours. I think the answer to the question is no, Papadoria, but maybe I'm not thinking of something. You get a divergent series. Oh, here we do. Okay, yeah, and this step here. Oh, so I thought you were saying it's insane because I was gonna do like I wasn't gonna do the thing he did with the real part. I was gonna do like e to the x plus e to the I minus x and like think about something with that. I don't know yet. This is at least a lot less algebra involved, but yeah, the series isn't good. That's weird though because syntax did do this numerically and got pi. So there should be something here. Um Oh, that's another interesting point, syntax, yeah. The real part of two complex numbers multiplied isn't the same as the multiple of their two real parts or whatever. Hmm. Yeah, so that's another issue, I guess. This doesn't seem applicable then. And that, I don't know how you would justify that. Hmm. It's within 10 to the minus 42 of pi over 8? Oh, hey, yeah. That's half the integral. Dude, that's so crazy. How it's just barely off of pi over 8. Yeah, cosine is even. So, but you're saying it's about pi. If the even thing, like, that's in conflict then, because we're not getting pi over 2. Made by a factor of 2? Okay. Well, plausible reasoning in the 21st century. I don't think that's it. Uh, oh. It's like a book. Identity below. Oh, this? The album? I don't know what to call it. She released an album all with singles. So if you look at her Spotify page, there's about 1 trillion singles that were released just this year in 2025. And I'm just going down the list of those. Span of the sync to sign. Okay. Uh, the Wolfram one? Srishti? Yeah, what are you trying to prove? Hmm. So really actually remember doing something with the Borwein integral for a final in a grad class? Oh my god. Sounds terrible. The Borwein does seem like a thing that exists. I agree, it does seem like it exists. It's very astute. I don't remember what sync is. Sin x over x? Oh. I didn't know that had like the cosine representation. Yeah, okay. This expansion is not obvious to me how, like why that's right. But we could believe it. I don't know if this is more convenient to work with. You know the proof? Okay. Start with the sine of x Euler product. Oh well, I mean, I don't care about the proof, to be honest. I care more about whether it actually helps us solve the integral. I'm okay with just believing that that's true. So can't we put this? We could change the sync back into sine x over x. Would we care to do that? I don't know, man. Yeah, I'm getting close to just calling it. I think it feels like there should be a trick. You starting on the 25th? Oh my god, that's soon. Oh. Soon ID working to get your bus fares cheaper? Yeah. Really? At the university that I went to, the student ID gave us free bus fare. And I think that's gonna be true for the school I'm about to go to. Oh wow, that's a funny way of saying it, but that it's every single permutation with plus and minus, which is the hard part. This is the sync idea, I think. Considers a Fourier transform and convert it into convolutions. Sure. The conjectures are known to be false. Is it slightly off of pi over 4? Or it'll be slightly off of pi over 2? So the same thing is true with the pi over 4, I guess. Huh. Oh, really, Lubird? Maybe we can try it. Fanwins does it better. Don't look at me. Or don't at me. So yeah, syntax. It seems like people have cited this problem. It's just in books or papers or something. Syntax. I feel like your destiny is to eventually learn every single integral technique. So and then to make the most cooked possible integrals using those techniques. I feel like I may have looked at, if not this exact one, something like it. But a key thing to notice here is that it's an even function. And it's easier to integrate from minus infinity to infinity. And so we only have a singularity at 0, right? Oh, are you trying to find like the Fourier transform of that or something? I guess we can choose a circular contour. I assume that's the play. C epsilon and CR. If S goes to infinity, f of s goes to 0. Too easy, baby, too easy. Okay, this is the path or way. All right, so we're gonna integrate, I guess, from r to minus r to minus epsilon, sine x over x. This is C1 here. We'll do C2 here. From epsilon to r, sine x over x. And then 0 to pi. Oh, no. Pi to 0. I'm trying to do C epsilon here. Sine epsilon e to the I theta? Question mark? Like that. I did some mental math there, which is always dangerous. And then for CR, sine RE to the I theta. RE to the I theta. Ooh. I need an epsilon here, don't I? So I took mentally z equal to epsilon e to the I theta. I feel like a conductor when I wave my pen around like this. Okay, and so these integrals are the one that we're interested in solving. These integrals are basically this integral here. And so I'm actually just gonna... Oh, and sorry, we know this entire thing's equal to 0. So from minus infinity to infinity. I'm translating these two back into the infinite thing. I think technically to justify that, you should show separately that these two integrals converge. But that's lame and for nerds. How do we deal with this? Well, this is potentially cheesy. U equal to epsilon e to the I theta, though? Because sine of u... Oh, wait. I'm dumb. No. It doesn't work. I think we need we need argument principle. Something like that. I forgot about that. I forgot. Yeah, yeah, you make it into E. Ugh. I've made that mistake before. I was wondering why it looks so weird. I'm so annoyed that I did it again. Um... This is still gonna look weird though, is it not? I think we still use wordings like Jordan's lemma or the argument principle or something, I think. I feel like I need to change the music again though. Like the integral is still weird to do with polar coordinates, right? We should just try to prove that something is 0 or some known thing. Probably not this. I don't know. We don't have... Wait, do we? No, we don't. Do we? I don't think so. Want something like this. This is a simple... Wait, is it... You can... It's easy to get fooled. It is a simple pull. Yes. So this integral is going to be... We need to figure out the residue. And for a simple pull, that's easy. Okay. Okay, so now I have a better idea of what to do. Just leave these things be. Don't try to go to polar. Okay, so then this thing, we have a minus sign out front. We're going to get another minus sign because of the orientation of the contour. I pi times the residue. The residue, it's a simple pull. So what we can do is we keep the numerator the same, take the derivative of the denominator, and then plug in z equals 0. So it's just e to the 0 is 1. So it's just minus I pi. This one, presumably is going to be 0, but we need to... So the thing we need to show is that z f of z approaches 0 as r goes to infinity. Is that even going to be true, though? Hey, mouse. I'm not sure this does. So if this is our f of z, then z times that is just e to the I z. And if we let r go to infinity, I think it's just unbounded. Yeah. Hey, Davy Jones. Um, I'm starting on a master's in a little over a month. A PhD would be cool. I'm planning to apply to continue on for a PhD. There's it's not a super high chance though. But yeah, right now I just have a bachelor's in applied math. All right, so I think this theorem that I wanted to use just is not going to be a thing. Cool, people who know for your job as math tutors. Oh, nice. I'm glad. Usually people have a like usually people just think of like all the bad math teachers that they've had and just have a pretty negative opinion of it, which is understandable. I'm glad to hear it's not like that for everyone. You had a sexy math teacher. There you go. That'll do it too. She was awesome too, though. Okay. It's good to hear. So the college started at the bottom. We learned a lot that I missed initially. Deeper appreciation for it. Oh, nice. Two awesome math teachers. One was an 8-year-old man. Yeah, I definitely had a good like 5th grade math teacher. I remember her. She put a lot of effort into teaching. And she was very like kind of like intuitive. She's an army vet survivor. Oh wow. This sounds like a hell of a life. Lagrange Inversion Theory. I sure don't. Oh, that's crazy, mouse. Wow. The Taylor series expansion of the inverse function of an analytic function? That's kind of wild. Sorry, once maybe 10 years later. Okay. What the heck? Oh my god, mouse. Both your math teachers have such sad stories. Holy crap. You tried but you failed to make an inverse function for f(x) equals root x. I mean, we can try to apply this. I don't know how much luck I'm gonna have. Hmm. So... Oh. Holy crap, Zone Ranger. Thank you so much for the Prime. I hope you've been well. I appreciate that. Oh, wait, not Z. I shouldn't say that too quickly. Not the letter Z. So the function that we have is the root of x, and we want to use this thing to try to find x squared. I assume we're going to do it about 0. People think if a BF does a bad thing to GF isn't a bad thing. Like in Portugal, or... There's probably people who think that everywhere, but like... In Portugal, wow. Yeah, I mean, I'm sure it's not only there, but that's, it's not good. G1, Z minus f of a to the n over n factorial plus... Oh, not n. Not Z. X. Oh my god. And that's 0. Zero squared over 2 factorial. Gonna study? Alright. Good luck with your studying. Thanks for sharing some sad stories and dipping, I guess. I don't know why I'm writing all this out, to be honest, but I've come this far and I'm not going to stop now. Alright, so can we work out what G1 is to start with? These should all be 0 except for G2. And G2 should be 2. I guess that's what we expect. I do wonder how this is gonna... Well... Oh no, okay, root x has a clear inverse with x squared. X squared is the one that has the weirdness. Might have been a wee bit stupid. Okay. I'm gonna do it anyway because I want to see what's gonna happen, but oh wait, so we're not taking the derivative for G1. So it's gonna be just x minus 0 over root x minus 0, which is 0. What's happening here? It's so weird how it's like, this is the, it's like the reciprocal of the slope, and then a derivative, and then a limit. It's like you smashed a derivative into the limit definition of a derivative. So it's just d dx of x, right? Because x over root x is just root x, and the root x squared is x. So this is just 1. But I should expect 2, shouldn't I? I don't know why I'm not getting 2. So we need to offset that 2 factorial. But yeah, I can imagine that for all the, like, the G3s and beyond will all be 0, because we're going to have a, like, 1 over x to some power. The derivative of that will still be 1 over x to some power. Oh, yeah, but that's not good, as x goes to 0. Okay, what does happen with G3 then? You do take 2 derivatives. Okay, x over root x is just root x. Let's just cut to the chase there. So x to the 3 over 2, 1 derivative is 3 over 2 x to the 1/2. Another derivative. This is bad. This limit isn't defined. Oh, well, this isn't analytic at 0. Or, yeah. I need to choose like 1 or something. But, okay. Let's try it with 1. The issue is root x is defined On what, 0 infinity? You can't be analytic right at an endpoint, I don't think. So let's try it about 1. Presumably that should work. F of 1 is just 1. Oh, wait. I should have paid more attention to that bit, too. Although F prime A would be more undefined, I guess. So. Okay. 0 is just a bad choice, I think. No derivatives. X minus 1 over root x minus 1. How do we do this? L'Hospitals? Zero? Good, probably. Also, I like how you spoke like Jar Jar Binks. Misa, not stupid? Okay, this is what we call a problem for Wolfram Alpha. Because I don't feel like doing that. That's a lot of work. Do 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 do. What from MATLAB bring back memories? Oh, did you use them for your math classes? That's 2. Hey, that's a good sign, right? Oh my god, why didn't I think about rationalizing? Thank you, syntax. Wolfram for calc, MATLAB for EE. Oh, nice. Yeah, I had to do MATLAB for like differential equations. You didn't rationalize? How did you find that? Geometric series? I don't see it, but Zone Ranger, the syntax is asking about the Lagrange Inversion Theorem, which finds the Taylor series for the inverse of a function. And G1 is going to get plugged in like right there in that sum. And so we're just doing a toy example with the root of x. Sure, more MATLAB? Yeah, it's a pretty convenient language. I want to learn Python because it seems more powerful. Like it just seems like maybe we're not. I don't know about. I can't say anything about the power, but it's more common now. I think with like the NumPy library in Python can replicate a lot of what MATLAB does. Oh, I'm sorry. You meant from actual like calculation. this is 0 over 0, right? So I just did L'Hopital's to get that result there. It's entirely possible I made a mistake. Oh yeah, you know what? That's not going to work out. I should get something. Do it again. Oh, yeah. Sorry, that's what you're getting at. I don't know how to take derivatives. That's my issue. Thank you, Zone. 2. And I think that's a good thing. Because this is going to be x minus 1 squared, and we need something from here to cancel it. All right, what a terrible mistake. Now, I expect G3 and everything else to be 0. We'll make Wolfram Alpha do G3 for us. And if that's 0, I'm going to just believe that everything else is 0. Easy use for most disciplines with Python. This is what standard where you work. Oh, nice. Oh, that's... Wolfram, can you do the limit for me too? What? I have to type all this in again, man? Bruh. It's not that bad. Be rashed, Wolfram. What type of work do you do, Davy Jones? If you'd rather not say, that's okay too, but I'm curious to hear. Okay, 0. Good enough for me. Proof by Wolfram. Okay, and so presumably g of x is 1 plus 2 times x minus 1 plus x minus 1 squared, canceling g2 with 2 factorial. Somewhere between engineering and wet lab sciencing. Okay. I don't know what wet lab sciencing sounds like. Some type of chemistry or biology thing. Battery technology. Okay, that makes sense. That's awesome. Okay, yeah, this works out. Math works. Definitely chemistry? Okay. So yeah, 0 is just a bad choice of point. That's kind of funny. Yeah, chemistry is one of the things that, like, I'd love to know better, but I just find it kind of a drag to learn about it. How can you approximate the charge of battery by looking at it? I definitely did that to my fair share of 9 volts to check their charge. I feel like I got decent at it. It's kind of crazy you can find the like, I did not think this would be possible to get a formula for the Taylor series of the functions inverse. Oh yeah, so the problem I was still wrestling with. 3 licks minus hysteresis? GTG. All right, Syntax. Thanks for hanging out and for the problems. See you around. So before that, we were working on the integral from 0 to infinity of sine of x over x using complex numbers. And I think I've nearly solved the problem. I'm just wondering how we deal with this infinite arc contour. The theorem that I would usually use for this doesn't seem to apply. Uh... Is it possible to just calculate it straight up? We're gonna have an e to the e is the issue. Can we use power series to deal with that? That might be the way. Oh wait, so I never heard this word before. Hysteresis? Hysteresis? Huh. That's cool. I've heard of this. Um, Energy left in a cell is always a guess. Oh, funny. I just kind of assumed that since like my iPhone says how what percent charge is left, that we'd have a pretty good idea of that. Maybe not though. Um, all right, you know what? Let's just try to use series to do that integral. I don't know if that's going to be a good thing or a bad thing, but I'm going to say 0 to pi e to the I r e to the I theta. R e to the I theta. I r e to the I theta d theta. Then I'm just going to split that integral off and work on that separately. Put an I out front, 0 to pi. So it's just e to the I r e to the I theta d theta. And what does that power series look like? We can integrate this term by term, right? These are just a bunch of constants. I don't know if we'll get something pleasant on the other side. Uh... I need to make sure the indices line up here. The first term in the series is just 1. So we still start from n equals 0, I think? No, that's bad. You once had AI describe hysteresis in terms of the thermal energy left in a mood ring after you take it off. Oh! That is interesting. And yeah, it is definitely the future, whether we like it or not. Isn't a series basically just a function that has a lot of rating and therefore you just write sigma? Exactly, yeah. The only thing the sigma does is it saves you from having to write out infinitely many things, or even just like a lot of things. And also, when you're doing calculus with this stuff, it sometimes kind of hurts. For the exact thing I'm doing here, I'm trying to integrate a series. I'm having a hard time doing it in this form, though. So honestly, I'm just going to break it out into individual terms, because I'm having a hard time going straight to the sigma version. So the first term in the series is still 1. So this is a little bit easier for me to wrap my peanut brain around. Theta plus I R to the I theta I times 1 factorial. The R the R is like for the polar form of a complex number, I'm using capital R instead of small r, and R is just the radius for that polar form. I'm using capital R here because I'm gonna make R go to infinity, and that's just kind of what the book I've been reading has been doing. Yeah, you can write any complex number as a radius times an angle, or e to the I angle. And so R is just that radius. Oh, wait. Have I not? Like, if you have the complex number 1 plus I, let me choose a better example. Actually, that's okay. You can graph it on the real imaginary axis as regular Cartesian coordinates at 1, 1, or you can do polar form, which is a radius from the origin R and an angle theta. And so you can say that 1 plus I is equal to root 2 e to the I pi over 4. And sometimes this form of complex number is easier to work with. Yeah, that's how you would convert back. So if we started with this and wanted to find the regular representation, we would use Euler's formula. So the root 2 stays out front, e to the I pi over 4 is cosine pi over 4 plus I sine pi over 4. Cosine pi over 4 is root 2 over 2. Sine pi over 4 is root 2 over 2. So multiply the root 2 in. We're just going to get 1 plus I. So yeah, being able to represent the same number in two different ways is a really important theme. And it's not just in complex numbers that you can do this. But in complex numbers especially, it becomes really important because... In fact, I feel like we usually deal with this form more often than we deal with the other form, at least from the problems I've been seeing it in the book. Oh, the thing I was getting stuck on is that the one just it integrates differently. That makes a lot more sense. Hey, Famished. What it do? Hope you're doing well. There we go. That's the summation form. So this R specifically represents, I'm using it to represent any point on this semicircle here. And I'm keeping it as a variable because I'm going to eventually make R go to infinity once it suits me. But I'm using polar form here because I'm trying to represent a semicircle. And so the R is gonna, I'm kind of keeping it the same throughout that circle. That's a weird thing to say. But yeah, it basically, it's representing a set of points here, all at the same like radius. And yeah, it's a little bit hard to explain because you've only like just learned the basic form of integration. What you would learn in a multivariable calculus class is that when you go to 3 dimensions, you can integrate along a path. And so I'm doing an integral along a path in the complex plane, which is something you learn in complex analysis. Hey, Joseph. I'm working on the integral from 0 to infinity of sine of x over x using complex variables. Trying to figure out what to do right now. Got the coffee, but no idea. Ooh. The world is your oyster. Find f prime of x of log of x using first principles. So I assume you're asking, like, if f of x is log of x, find f prime of x using the limit definition is basically what this is coming down to. I don't know if I've done this exact one before. This seems kind of challenging. With the integral, Joseph, I've chosen a semicircular contour with an indent at 0. I have found that the small indent around 0 evaluates to I pi. Oh, I should have said first, it's an even function, so I'm letting the integral go from -infinity to infinity. And I'm going to divide it by 2 at the end. The thing I'm working on still is the semicircular contour that goes out to infinity. I'm trying to use series to actually integrate it. It's not looking very pretty so far. I'm hoping it cleans up in some way, though. See, I'm not quite sure what to do with this. We could think about the other limit definition of a derivative. Is that easier to work with here? Oh, all right, you found it. Yeah, that limit right there seems like it needs some justification. uh But if you're able to find that, then I'm just going to leave this one here. So I know about Jordan's lemma, but it didn't seem to apply. Where is it? Oh my, I was looking at the wrong one. I was looking at a different theorem that didn't apply. Oh wait, but no, I'm not. Oh wait, yeah. Oh my god. Okay, never mind. Jordan's lemma. Okay, thank you, Joseph Integrates. It definitely applies. I looked at the wrong thing and I thought it was Jordan's lemma, and I was confused when it didn't apply. Like in theory, I should be able to get 0 out of this power series. I'm kind of curious if I can make that work. But yeah, so we'll just find that the integral from -infinity to infinity is I pi. And so the answer to the question should be pi over 2. So we're going to take the imaginary part. Oops. The original question was 0 to infinity. Hey, Renga. Yeah, I was working on this integral here with complex variables. They have actual people explain the material they give you graded assignments. Ooh, nice. And Lucas, that log identity is only for multiplication. Log of, oh my god, terrible handwriting. Log of x times h is log x plus log h. So it doesn't apply there. You can audit it for free, but it's $50 to get access to the grades within certificate or to show you completed it. $50 isn't bad. So yeah, we theoretically just found the answer is pi over 2. Why don't you just make that identity out of thin air? You know, there's nothing stopping us. Curious if that would work. Yeah, I kind of want to play with it just for replace a little bit. Because theoretically, like, we should be able to justify there's a lot of cancellations happening there. They're going to have to, because R is going to go to infinity, so it better be multiplied by 0 before that. Like that is what we get. So used to doing low-cost programs is my best option. I would need to research a way to tackle it for applied math. Oh yeah. Applied math is a bit more niche. This definitely feels like we're getting cancellations. Because this is just it's either 1 or -1, right? Yeah. Is that not? No, it's not possible to just pull that math out of thin air. No. You the entire point is to prove it. You can't just make up identities that are convenient. So this is it's the same thing as -1. When n equals 1, it's e to the I pi, which is -1. So -1 to the n makes sense. What? Famished? I don't know what that means. I don't know what it was but before. Multiply 0 by both sides. You know, you may as well. Sterling's help? Maybe, I don't know. I don't know Sterling's. So, we're only keeping the odd terms out of this? This seems like a whole mess. Oh, you might have done the... Oh, okay, yeah. Theoretically, this should equal I pi. Don't ask me how. So, okay. IN or IR in the denominator? It should be IN, I think. The IN came from the integration of e to the I theta n. And so I had to divide out an IN because of that. That's where it came from. So I want to cancel this I with that, because we get an I to the 2n, and that seems like a thing. I hope it's a good thing. Go for checkmate. So I to an even power is always 1 or -1, right? So this is bad. This is just bad. I wonder if this is one of the ones where you don't want to simplify it. Like, you want to make it look like the series for a known function. Because I'm thinking throughout all this is that I need to eventually take R to infinity. And this is not gonna help us. Oh yeah, Renga. And so we have actually solved it. It should be pi over 2. Where this came from is I was doing I'm using this contour just like a semicircle, and the thing that this came from was the integral for the big semicircle that's going to go out to infinity. And I completely... There's a way easier way to do it than what I was doing. I forgot about Jordan's lemma. Like, this entire thing, it should just be 0. I had already started doing it this weird way with series, and I just want to see if I could get 0 doing this weird series way also. This is a really bad way of doing the problem, though. And I just hit a point where I'm about to just quit on this approach because it's getting kind of stupid. But yeah, I just want to see if I could magically get a 0 from this, because in theory, it should be possible. I'm just not really seeing it. And everybody know that I love Jordan during complex analysis class. His name is kind of all over the place. Yeah, Rob, that's the other reason why I just want to quit on this, because it's very possible I made an error. Oh, I sure have not checked each step. I'd rather not check each step. Let's look how many steps I wrote. Inappropriate jokes surrounding his name. Because it depends how inappropriate. Like, if it's Twitch friendly, I wouldn't mind hearing it, but if you're not sure, maybe better to play it safe. I don't mind like cursing or like dicks or tits or stuff like that, but okay, no worries. Um, all right, well, doing that integral the right way is interesting. Doing it the wrong way is debatably interesting. um, okay, I probably won't stream for a ton longer here, but your brain cannot be bothered to mine either. We can pull a problem to study. This is from the complex analysis book that I've been looking through. What was it doing? It's this book. It's just kind of okay. Doing limits. Rob, do you want to see a certain type of limit? If you have a question, I'd be happy to answer it. We can look a little bit more at Cauchy's theorem. So I basically read through, skipping over some sections that are marked as optional. I've read through all of chapter 4 of this book. Go to JE. Oh, okay. Yeah, sorry. I've tried JE questions before, and they're a little bit too rough for me. Start teaching math in less than 2 weeks? Oh, man. What class? Or classes? Yeah. These are jumping out to me. Hey, sesquipedalian? I don't know how to say that, but welcome in. Nothing theoretical? Oh, okay. And I assume that's your preference? I have a major in applied math. Preference is being employed. It's a pretty reasonable preference. I remember I did number 5 the other day. What does number 6 say? How would we approach this problem? The Laurent series for an integral function? This book is pretty applied in its leaning. It's like even like it brings in like fluid dynamics and differential equations as early as it can. But honestly, like complex analysis, it's kind of just a likable part of math. Like it just serves to kind of help with existing problems. It doesn't pose annoying problems of its own for the most part. So I find it pretty likable. Yeah, I mean, this is just a PDF of a textbook. Page 143. It's this textbook here. It's posted in my Discord. It should still be there. Yeah, if you're in the PDF, I can point you towards it. Oh, thank you for the 10 bits, Famished. Appreciate it. Yeah, I think I added these in myself, to be honest, because I really love having bookmarks in my PDFs. And so I've gone through a few books and added in my own like bookmarks because I just need them. Twitch added a new feature where you can use your own Twitch revenue that's in your account for bits and subs. That's kind of cool. I haven't seen that. Complex analysis strange. I understand complex analysis, but not real analysis. I know the real analysis bit's relevant to integration, but not really much else. Honestly, I feel like real analysis is more proofy than complex analysis. So I get that. Jermaine, what sites to use for practice problems besides Paul? You know my tricks. So I have the same issue as you. Honestly, I would just find textbooks and pull problems from those. Because I don't know of many like websites. I'm assuming you're talking about more advanced like math things. It's just like arithmetic that there are sites for that. But for anything that's not arithmetic, oh no, I'm doing it bad. This site has a bunch of free and legal textbooks. And so I would just pull something from this and do problems from that. The preview pedantic bits I can't be asked with. Yeah, that's understandable. Yeah, I'm sorry, it's not as exciting as just a website, Jermaine, but as far as I know, the thing you're looking for doesn't exist in general. You could try looking for it for your specific niche, but yeah, I don't know. What channel is it on? Yeah, let me show it. Come on. In the CA reading group, at the very bottom, check the pins, and it'll be that PDF right there. It's also not hard to just Google the name and author of the book and find a PDF too. But that the one that I posted has all my my bookmarks. The ones out there online doesn't. Luminous. Oh, I've seen it before. I don't remember the proof offhand. I know you use squeeze theorem. I'd have to look it up again to remember how it goes, though. You got it right now? Nice. OBS Live, let's sneak attack him with bits? Hell yeah. Sound a little bit over the top. Something in me says something exists, which is not positive or negative. Can't say what it is. Well, 0? There's that. Oh yeah, if you're allowed to use power series. That's an easy way. Yeah, the way that I think is theoretically better is to do it the squeeze theorem way. But the power series way is nice and quick. I meant like summation or the other. Well, there's a big product that's like summation but with multiplication. But I'm not sure if that's what you mean either. If you think complex analysis doesn't pose many problems, check out volume 2. I was wondering if I would get called on that statement. It kind of sounded wrong as I was saying it. At least for the complex analysis that is normally first, like, it is a really deep topic that poses its own like questions, but I feel like most things that you learn about it at first, at least, just exist to help you out with your real number problems, like with really difficult integrals or differential equations and stuff. Oh, so defining other operations than just adding and subtracting, and I assume multiplication and division. Yeah, that's basically like you would study stuff like that a lot in like abstract algebra. That's basically what abstract algebra is talking about. Like you can talk about things that aren't just addition and subtraction and things that aren't just numbers. That's abstract algebra. Yeah, I'm starting on a master's in a little over a month. Can I what if I Google that book that Puika said? Okay, yeah. I can't find it as a PDF, but I definitely believe you, Puika. Yeah, it'll be Masters in Applied Math. Yeah, like Diamond. Class am I most looking forward to? I'm in the first quarter I'm going to be taking mathematical biology. I'm excited for that a lot. Then I'm interested to learn more about like PDEs. That'll be in like the third quarter though. But yeah, I haven't looked at what all the electives they offer. But those are the two that are like on my mind. They would call it just a master's in math. You can find, like, depending on the university, their master's in math could kind of go in a few different directions depending on your choice of classes and what their faculty prefer. So like Zach has a PhD in math, but he kind of bends more towards education and analysis in his math PhD. Having a literal master's in applied math in name is a little less common. In like the school that I'm going to has a separate applied math department, and that's separate from the regular math department. It's a lot smaller, and I think we're like less funded, but it's there. But yeah, I would say that like masters in pure math is the default. They call it just math though. The masters in applied math is kind of like the less common, I think, more recent thing. What was I looking for again? I was looking at problem 6. And do we start with Cauchy's integral theorem? Actually, what does an integral from z to infinity even mean? I guess it's independent of path, so it doesn't matter. As long as we don't go through 0. Or... what's the word? We can't go through 0, and we can't wind around 0. And close. Oh, sorry, when I say Zach, I mean eats a 2a pi, by the way. Okay, what does Cauchy's integral theorem say again? This is really... Cauchy's integral formula is the one I want. This is one to get like tattooed on you if you're gonna get a math thing tattooed on you, it seems. Does this line up with the actual problem? Let me take a screenshot of this because I'm not gonna remember what it says. It doesn't. This is not the right format for Cauchy's integral formula. Does it though? Oh wait, could this be like the... Ooh, wait. Could it be the one with derivatives? Could it be this one? Take a screenshot of this, go back to the problem. Oh, no, it still can't. Wait, can it though? I don't think so. Maybe it can. Okay, let me get my journal plus set up here. I want that screenshot. I want that screenshot. Okay, so if my f of, I guess f of zeta, I hate zeta, is e to the minus 1 over zeta. what happens here? Because we can consider this as t minus 0 squared. That's okay. So naz is 2 pi I over 1 factorial times e to the minus 1 over t prime evaluated for t equals 0, which is going to be an issue, isn't it? I was wondering if the derivative would somehow fix this. I don't think it really is. So maybe Cauchy's integral formula is not the play. What is the play? Are they saying what to expand around? I guess we expanded around 0. Oh, wait. That's kind of funny. They're saying to expand it for everywhere outside of a circle in the complex plane. Huh. So maybe we find the Laurent series for just e to the minus 1 over t squared, and then we integrate it? Is that the strategy? It's probably, that probably should have been the first thing that I thought about. Okay, and then we can bring the t squared inside. And we can hand wave something and say we can interchange the sum and the integral, because that's just what we do. Now we integrate this. And so, do we have to be careful about any particular powers of t? I don't think so. Maybe not. Probably not. Oh wait, we're getting another negative. Because it's a power of negative n minus 2. I guess I'm doing that. I'm sneaking that in. No, it's... Dang it. It's n minus 3, right? Oh, wait, but you divide by the new power. Bruh. You do need to be careful about certain powers of t, because 1 over t doesn't integrate in this pattern. Oh my god. Back it up. Just write it out term by term. I can't handle... Actually, you know, we don't even need to interchange. Or it's not yet. Okay. I'm so bad at integrating a series directly. I need to see the individual terms. So this will be 1 over t to the minus 2, so just t squared. When t equals 1, get a minus sign. We get a 1 over t to the negative 1. When t equals 2, get plus t to the 0 is 1. 1 over 2 factorial. Gonna get minus n equals 3 now. There we go. This is the one that will integrate differently. ChatGPT says you were cooking, but well, he's probably wrong. ChatGPT is a very agreeable thing, as far as I know. So yeah, I wouldn't trust. Trusted that it's definitely right. Now everything else here can get integrated with a pattern. Okay. Is that like a wedge? I think it's a thing in math, like a wedge operator. Don't know how that can go wrong. Me neither. Okay, so what does that look like as a series? Like that? Based asymptotic series? Hope you're doing well, Fizzbuzz. I don't really know what's happening in this problem. I'm just kind of feeling my way through a room with the lights off. So, okay, the point of doing this is that this integrates cleanly, unlike that. And so it's a power of t to the minus n. I have a problem. Okay, wait. T squared integrates to, or 1 over t squared integrates to 1 over t. Oh my god, why is this so difficult? So it should be like n minus 1. I need to divide out a negative n minus 1 though. Is the trick. And this series should start, our first power should be 1. So we start from n equals 2. N. I think I got that right? Question mark? Well, this is just diverging, so that sucks. Life sucks. As soon as I got any of these terms, this diverges. I don't know. I don't see the error. There probably is one somewhere, because I shouldn't be getting diverging behavior like this. But that might be a problem for future Dawn. Yeah, I don't see it. I think my brain needs a break. So maybe we'll call it there for the stream. It's annoying. I feel like I did it right, but I don't know. I'm sure I'll figure it out eventually. But yeah. I've got this YouTube stream off here. On Twitch, we'll look for a raid. People are on YouTube. Thanks for being here. And see you later, YouTube. Bye, Jermaine.